Welcome to the fifth and final episode in the serialization series. Let's talk about some little tricks you can use to improve the maintainability of this type of code. The big deal here is that so far we've been writing our reader and our writer functions separately, and they're sort of mirrors of each other, and they have to be. You have to write every element and you have to read every element in the exact same order, in the exact same way that you wrote it. Otherwise, you'll get out of sync. And this tends to be a big opportunity for bugs. What happens is everything's fine, and then someone adds a new data element. We add something new to our structure. We need to remember to put that into our serialization, and that can be quite tedious. Maybe you remember to put it into the reader, and you forgot to put it in the writer. Or you have some typo where you put it in the wrong order in one or the other, or you put it in the wrong format, or something like that. Can be a bit of a pain. So the read and the write have to be maintained in sync all the time with every change you made. Lots of opportunities for bugs. So what do we do? Here's a trick. There's a little trick you can do to really improve that, and that is to write a single serialize function that works for both reading and writing. If you have a generic serialize function that can be either reading or writing based on whether this bool returns true or not, then we only have to write it one time. And we don't have to write like a separate reader and a writer. There tends to be, interleaved in the serializer, sometimes a little bit of, if we're reading, do this, if we're writing, do that. But we do it on an element by element basis as opposed to on the entire function. And that really helps you keep them in sync. Okay, taking that idea further, one of the things that can be very irritating is just remembering that you have to serialize your data at all. And a lot of times we have designers, project designers who use tools to create new data elements for us to access, and we don't always even know that that needs to be then added to the serialization. So what you can do, and it takes more work, is to set up something called reflection. In a reflection system, you would have a tool of some kind that automates the parsing of your data structure. It would know it's in the data structure and then automatically serialize that for you. Can be auto-generated by a tool. What people do a lot of times is they will create like an XML file or a JSON file, some type of file like that, that describes the data and says, I have an integer called this, I have a float called this, I have an array of this type called this, and you put that in there. And then as a pre-compile step, that file will be read in and used to generate the header files that describe your data structures. It will also then generate the code to serialize and deserialize that data structure. So now you're guaranteed that the code to serialize and deserialize, the code that reads it, the header files, and the tools that generate the data are all kept in sync that way. Taking that even further, you can encode into the data serialization some metadata that describes the data itself. So rather than just including a byte stream that is the series of bytes for integers and floats and strings, oh my, you can embed in there a little piece of header that says the following is an integer. For example, like you could say the following is an integer, and then comes an integer. And then you could say, this is a string, and then you put a string. And you'll notice that we are leveraging the serialize abstraction. So this is both the reader and the writer for this data stream. All right, that was a short one. That's the end of the serialization class. I'll see you in the next one.